So the function f is continuous on the closed interval and it is differentiable. It is differentiable on the open interval. On the open interval a, b, we need a third condition that says f of a is exactly equal to f of b. طيب, what happened if these three conditions are satisfied? The theorem says there must be a number c in between these two numbers a and b such that the derivative of the function at that point is equal to 0. And it means we have at least one tangent is horizontal. We have an a is here. We may have something like this. Okay, maybe more than one, like what is appearing here. So we have the derivative at this point is equal to 0. The derivative at this point is equal to 0. The derivative at this point is equal to 0. And we call this one rules theorem. The second one, if you remember, is called the mean value theorem. And this is the summary of it. It says if you have a function f that is also continuous over the closed interval, differentiable over the open interval, we forget about the third condition. The theorem says there is at least one c in the interval for which what? This is what we have here, such that f of prime of c is equal to f of b minus f of a over b minus a. And geometrically, we said this means that there is at least one point on the graph whose tangent is parallel to the secant line joining the 2 points a and f of a, b and f of b. And this is the geometrical meaning, as we said. We have the blue line here, this one is parallel to this line. Of course, here we have two lines that are parallel to this line. So we have 2 points satisfying the mean value theorem. If you have any question about these points, otherwise I will go to solve exercises about the mean value theorem. If you have any question, please. طيب. As we said, the classical equation always in the final will be the value of c that satisfy the mean value theorem of this function s. That is the very famous classical equation. Verify that the function satisfy the hypothesis of the mean value theorem. You should remember the hypothesis. You should remember that the two conditions we have. Then find all numbers c that satisfy the conclusion of the mean value theorem. And here is an example. 2x squared minus 3x plus 1 over the interval 0, 2. Okay, you can see clearly that this function is continuous if, as we said, among the list we mentioned last time, f is continuous on the closed interval 0, 2. By writing the conditions, you will illustrate that you understand the meaning of the theorem. The function f is differentiable on the open interval 0, 2. These two are true because the function we have in front of us is a polynomial. And we know that polynomials are continuous over their domain, and the domain of polynomials are all real numbers. So they are continuous and differentiable specifically in this, interval we have. Jade. What is the conclusion? What is the conclusion? These are the two conditions we have for the mean value theorem. So the conclusion then by the mean value theorem, by the mean value theorem, what do we have? There is at least one c, there is a number c in between the open interval 0, 2, such that we have the following, such that f prime of c must be, let me write it downstairs here a little bit because we need space. So such that f prime of c must be equal to f of the endpoint, that is f of 2, minus f of the beginning, f of 0, over 2 minus 0. And we said the right-hand side here stands for the slope of the secant line. So that's exactly what we need to apply. So the first step, we need to find f prime of x. What is f prime of x? F prime of x is equal to. First, let me see if I put a space here. Okay, we can always move, no problem. F of prime of x is equal to what? 4x minus 3. 4x minus 3. Okay, so what do we have here? If we apply f of prime of c will be equal to what? It will be 4c minus 3. So this implies 4c minus 3 must be equal to, what is f of 2? Let us substitute by 2 here. 2 squared is equal to 4. So I have 2 times 4 minus 3 times 2 plus 1. 2 times 4 is 8. 8 minus 6 is equal to 2 plus 1, that is equal to 3. So f of 2 is equal to 3. Minus f of 0. F of 0 clearly is equal to 1. So 3 minus 1 divided by 2. The answer is equal to what here? 3 minus 1 is equal to 2. 2 over 2 is equal to 1. So this implies, if you like, C is equal to, لاحظوا, if you take 3 to the other side, it will be plus 3. So we have 1 plus 3 is a 4. 4 divided by 4 is equal to 1. And clearly 1 belongs to the interval 0, 2. You need to be careful. The numbers you should achieve, you need to choose the point that is in the open interval 0, 2. So the value of C here that satisfies the mean value theorem is only one value, and it is exactly equal to 1. I didn't have it in mind, but now let me just take this one, okay, and show you the meaning of the geometrical meaning of the solution we have found. So let us try to illustrate something here about the geometrical meaning of the solution. Okay, fine. This is what we have. This is the function we have. طيب, جيد. I don't like this. I don't need it. طيب, what is the graph of this function? Anybody can find out the graph of this, how it looks like? At least generally, what is it? What does it represent? You have it in 001. What is this?
Parabola.
It is parabola opening upward, isn't it? I need to find the vertex of this. And you know the vertex by 001, it is minus b over 2a and f of minus b over 2a. That's what we did in math 001. And minus b here is just 3 over 2a, يعني 3 over 4. Substituting 3 over 4, I have 2 times 3 over 4 squared, that is 9 over 16, minus 3 times 3 over 4, that is 9 over 4 plus 1. So that is equal to 9 over 8. صحيح? 9 over 8 minus 9 over 8, is it? Minus 9 over 8 plus 1. Okay, check my calculation. This 3 over 4 squared, 9 over 16 multiplied by 2, that is 9 over 8. Minus 3 times 3 over 4, that is 9 over 4. Sorry, that is 9 over 4. Okay, 9 over 4 plus 1. Now it is correct, I guess. So let us make the calculation part here. This is all over 8. So I have 9 minus 18. I multiply by 2, and I add plus 8 here. So that is equal to what? Minus 18 plus 8 is minus 10 plus 9, that is minus 1 over 8 if there is no mistake I made in the calculation. This is minus 1 over 8. Okay. Sent. طيب خلاص, I don't like this calculation part. Let me erase everything here. It's minus 1 over 8. Okay, let us now sketch the graph. 3 over 4, and this is what we have exactly here. But I can't find also the zeros of this function if I like to find the intercept, I mean the x-intercept. Let me try to factor out, if possible. This is 2x times x, and this is minus 1, I guess minus 1. So it is minus 2, minus 1, minus 3. So I have two zeros, 1/2 and 1. I have 1/2 is a 0 here, and 1 is a 0 here. And I have 3/4, a 3/4 somewhere between 1 and 1/2, and minus 1 over 8. Let us say something like this. Okay, we have it between 0 and 2. At 0, we said it's equal to 1. So the graph is somewhere here. And at 1, it was what? 3, is it? 2 minus 3 is minus 1 plus 1. At 1, it's equal to 0, actually. This is equal to 0 here. لاحظوا يا شباب, this is the graph of the function coming through this line like this and something like this. This is the graph of y equal to f of x. Now, if you look carefully for the secant line joining the endpoints, the secant line joining the endpoints, let me graph it in this color. So this is the graph of the secant line joining the 2 points we have. And this point is a 3/4 and something. According to our calculation here, according to our calculation, we end up the answer is C equal to 1. أنا غلطان عوضت بس بالواحد وبالاثنين. Okay, why not? Let's come back, and we are not discussing up to 1. We are discussing up to 2. At 2, it's equal to what? 2 squared, we said 4. 4 by 2 is, the answer is a 3 here. So it is at 2. This is equal to 2. And we have it up to 3. It means somewhere here. Okay. So this is the point. This is the point 2 and 3, which is the end point of this. Now, what is our secant line joining the 2 points? This is our secant line joining the 2 points. The theorem says there's supposed to be a point between 0 and 2 for which the secant line is parallel to this. The secant line is parallel to this. طبعا my graph is not accurate enough because we have -1/8, which is almost close to the x-axis. So let me adjust it a little bit. So we have something like this. Yeah, very, very short distance here coming. And then we go up like this. This is the point here, 3/4 and -1/8. So according to our calculation, طبعا if the graph is accurate enough, you will have this tangent here at 1, this tangent line is parallel to the line given between 0 and 1, 2, and 3. So this line is parallel to this line. If you have any question regarding the geometrical meaning of the solution, please, you can either raise your hand or open the mic and ask your question. I hope this is clear for you. طيب, if it is clear for you, write number 1 so I can take your attendance now.
Okay, Doctor.
Yes, go ahead.
Yeah, okay. So the theorem says that the line between the endpoints will be parallel to the line on the point we found.
Yeah, the point we found at c equal to 1, at x equal to 1. Okay, we have a tangent line to the graph there because the function is always differentiable. That tangent line must be parallel to the secant line. موازي إليه على الأقل مرة واحدة. So in this case we have it at c equal to 1. تلاحظ المستقيمين متوازيين. طبعا الرسم مش مرة دقيق لكن if you graph it accurately you'll have it exactly parallel. Yes.
And the second line is between the endpoints.
Yeah, the first point and the last point. Yes. Okay. That's exactly what the theorem says. لاحظ النظرية هنا في الأسفل أو في الأعلى هنا. This is what we have. There is a point C such that f of prime of C equal to f of B minus f of A على B minus A. هذا شنو f of B minus f of A على B minus A? This is the slope of the secant line اللي يجمع النقطة الأولى والأخيرة, صحيح? And what is the meaning of f of prime of C? It is the slope of the tangent line. Yeah, the slope of the tangent line will be equal to the slope of the secant line at least 1 time between A and B. That is the meaning of the theorem geometrically. Any question, please? طيب. We will do more exercises about the theorem only, and that is another one here. Says find the C that satisfy the mean value theorem. Okay, is this function satisfying the two conditions we have? What is the domain of the function here?
real numbers except minus 2.
أحسنت. real number except -2. وإحنا نعرف إن rational functions are always continuous over their domain. They are differentiable over their domain. يعني بمعنى آخر, this function condition number 1 is satisfied if is continuous on the interval 1 for y. I will mention, sorry, this is closed. And the second one, if is differentiable on the open interval 1, 4, because I will say since simply -2 does not belong to the interval 1, 4. The point of discontinuity, which is infinite discontinuity here, does not belong to our interval. It is a rational function, and rational functions are continuous and differentiable over their domains. Jimmy, يعني the two conditions of the mean value theorem are already satisfied. Jimmy, and what should we do? We need to find what? F prime of x first, then we apply the mean value theorem to find the answer. I have x over x plus 2. لاحظوا, what is the derivative of x? It will be 1. This times the second one, it will be x plus 2. هذا the derivative of the first times the second minus the first one is x, derivative of the second one is 1. So that is only x over x plus 2 all what? Squared. طبعا لاحظ ان x minus x will be deleted here. So I have 2 over x plus 2 all what? All squared. Now by mean value theorem, what do we have? By mean value theorem, by the mean value theorem, we have the following. There is, as we said, always, there is a number C, there is a C in between the 2 points given here, which is 1 and 4 open, such that, as we said, f prime of C, اللي هو 2 over C plus 2 all squared must be equal to what? F of 4, is it? F of 4 minus F of 1 divided by 4 minus 1. And this is F and only F. 2 over C plus 2 all squared is equal to. طبعا let us substitute now F of 4. 4 over, it will be 4 over 6, isn't it? 4 over 6, which is equal to 2 over 3. So I will take this calculation and put it here. It is 2 over 3 minus f of 1. نعوض بالواحد يطلع عندي 1 over 3. This is 1 over 3 divided by 4 minus 1, which is equal to what? 3. Now, if you simplify, this implies 2 over C plus 2 all squared is equal to. Okay, I need to stop now writing in the chat. Yeah, Bender will be the last one, yani. Okay, so try to stop writing in the chat, please, now. 2 over 3 minus 1 over 3 will be 1 over 3 over 3, that is 1 over 9. The right-hand side is simplified to 1 over 9. Now, when I multiply crossway, I have C plus 2, لاحظوا, all squared is equal to what? Is equal to 18, is it? Okay, this is 18. As we said, 2 over 3 minus 1 over 3 is 1 over 3. Over 3, that's 1 over 9. So this will give me two numbers, actually. I have C plus 2 is equal to plus or minus radical 18. Radical 18. مو قلنا يا عمر خلاص, stop writing in the chat, please. Radical 18 is 9 by 2. 9 by 2, so it will be 3 radical 2. 3 radical of 2 after simplification. So this implies I have two values now. Either C is equal to minus 2 minus 3 radical 2, or I have the second one, C is equal to minus 2 plus 3 radical of 2. The question now, which one of them is inside the open interval? I have the open interval between 1 and 4. Is this number between 1 and 4? This
No.
is not inside the point 1 and 4, so it is rejected. Okay? What about minus 2 plus 3 radical 2? 3 radical 2, radical 2 is 1.4 تقريبا. When I multiply by 2, that is 4 point something. Minus 2, 2 point something. Yes, this one belongs to the interval 1 and 4. So I have one value of C satisfying the mean value theorem in the given interval. Any question, please, before I go to the last exercise here for the mean value theorem? We have another applications, but in this kind of application, that is finding the value of C, the classical question, as we said in exams, find the value of C that satisfy the mean value theorem. طيب, let me see again if I left a space here. Okay, enough. طيب, what about this function here? What can you say about the exponential function? We can say that the exponential function is continuous over its domain and differentiable over its domain, and the domain of exponential function is the set of all real numbers. So number 1 and number 2 in the conditions of the theorem are both satisfied. Number 1, number 2, f is continuous on this interval 0, 3, f is differentiable on the open interval 0, 3, both of these because the function we have f is an exponential function. Okay, let me say it's just exponential function. I will write it down here, function like this. Because this exponential function, we have it continuous, we have it differentiable over that interval. Now, what is f prime of x? By the chain rule, it is minus 2 e to the power minus 2x. I found also now the derivative of the function. I will use now the mean value theorem to find the answer. If we just take this one little bit down like this. Okay, good. Now, by mean value theorem, we need to have a value of C. So I will say by mean value theorem. So by I will write here mean value theorem like MVT. There is a number C. What is that number? In between the given interval, and the given interval is 0, 3. So between 0, 3 open, such that we have the following: f prime of C. What is f prime of C? Minus 2 e to the power minus 2c. Minus 2 e to the power minus 2c must be equal to f of 3. What is f of 3? E to the power minus 6. E to the power minus 6 minus f of 0, that's equal to 1, divided by 3 minus 0, that's equal to 3. Solving this equation, you have, okay, I will divide by minus 2. I have e to the power minus 2c is equal to e to the power minus 6 minus 1 all divided by minus 3. It seems we need to also move this one a little bit down. So let's do that and then solve the equation. يلا مين يقول لي what should we do now? What should we do to find the value of C? Yes?
You divide by minus 2, right? So
this is minus 6. Accent. Minus 6. Yes, minus 6. What should we do now?
Simplify.
What should we do?
Len.
Yes? Take ln of both sides. Accent. Take ln of both sides. So this will give me minus 2c is equal to logarithm of the quantity we have there. I will write it as 1 minus e to the power minus 6 divided by 6. And finally, this implies the value of C is equal to minus 1/2 times logarithm of 1 minus e to the power minus 6 divided by 6. Let us make sure that this number is inside. It must be inside since it has only one number and the theorem guarantees the existence of such a number. It's supposed to be between the interval. But can anybody help us by using a calculator to find the value of this? 1 minus 1 over e to the 6 all over 6, take logarithm and then multiply by minus 1/2 and give us the answer? Can you do that and find the final answer? I underestimate the space needed for that question. Sorry for this. Okay. Can you just calculate it with a calculator and give us the answer for that specific exercise?
طلعت معي 0.9.
What's that?
Yes,
0.9.
Yeah,
0.9. Okay,
Yes.
so
Yes.
let me say this is approximately equal to 0.9, which belongs to the interval 0, 3. هذا النوع الأول من المسائل على mean value theorem. The mean value theorem has plenty of exercises. I will list some of them. This is one of the classical questions. Another exercise which is repeatedly appears in the final exam is exercise, or the example given in front of you now. I will do 2 exercises similar, and then I will move to a third type of exercises about the mean value theorem. السؤال هنا يقول f of 0 is equal to minus 3. Assume that you have a function satisfying this. F of 0 equal to minus 3 and f of prime of x less than equal to 5 for all values of x, for all x. يعني it is differentiable for all x. Find the largest possible value of f of 2. f of 2 cannot exceed a number. What is that number? طيب شلون نطبق والله المين فاليو ثيورم في الحالات اللي زي كذا؟ سهله جدا المساله. لاحظوا الارقام المعطاه f of 0 هو يسالني عن شنو؟ f of 2. The key here, one application for the mean value theorem, we will apply, I will tell you to apply the mean value theorem on the interval what 0, 2. Can we do that? The question, can we do that? Are the 2 conditions satisfied? Are the 2 conditions satisfied? وليش؟ من يقول لي؟ We need 2 conditions. What are they? We need the function to be continuous on this interval, and we need it to be differentiable on the open interval. Are these 2 conditions satisfied or not?
Yes.
Why?
The first is because it's differentiable for all of x, and the
Okay,
second
so-
is also because it's all differentiable by x.
أحسنت. The first one, it is continuous because it is differentiable everywhere, so it must be continuous everywhere, specifically for 0, 2. And it is differentiable, it's given f of prime of x is always less than or equal to 5 for all x. يعني it is differentiable for all x. So I will say condition number 1 and condition number 2 are satisfied, and you should fill in the space here because f is differentiable, and differentiability implies continuity. So it is enough to say that f is differentiable. طيب لما نطبق النظرية الآن by mean value theorem in this, what do we have? نظرية شو تقول؟ تقول there is what? There is, let me write it by the mean value theorem. So by mean value theorem, what is the conclusion? There is a number C, there is a number C in between the open interval 0, 2 such that هذا النوع مسائل هذا مهم جدا للفاينل اكزام، مرة مهم. such that what؟ شو يكون؟ نتيجة f prime صحيح of C is equal to what? f of 2 minus f of 0 divided by 2 minus 0. 2 minus 0. جميل، التفتوا لي شوي الآن. هو عاطيني في السؤال شنو هو؟ عاطينا ان ال f prime is what? Less than or equal to what? 5 for all C, for all x, يعني for all C also. So what can we say about f prime of C? Isn't it less than or equal to 5?
Yes.
Yes, so what can we gain here? We will have the following: f of 2 minus f of 0 divided by 2 is less than or equal to what? Equal to 5. لأنه معطاه في السؤال less than or equal to 5. So this implies شنو؟ f of 2
Is equal
minus f of 0 is less than or equal to 10. So f of 2 must be less than or equal to 10 plus what? F of
Negative 3.
zero.
هذا كم يساوي هذا الكلام؟ f of 0
It's
is given in the
given.
question.
7.
minus 3.
Yes.
10 minus 3 is equal to what? 7. فمستحيل قيمة الدالة عند الاثنين تتعدى 7. يعني the maximum possible value for f of 2 is 7. فلو جالي في اختبار بطريقة أخرى مثلا قال لي given that f of 0 equal to minus 3 and f of prime of x is less than equal to 5 for all values of x, then which one of the following is a possible value of f of 2. وأعطاني مثلا في الإجابات أعطاني مثلا 6 8 9 7.1 10 11. Of course I will choose the number which is less than or equal to 7, and that is the number 6 in the choices. Can you now apply the same strategy I did in this exercise number 25 in the book that says, if you are given that f of 1 is equal to 10, and you are given that f of prime of x is less than, greater than equal to 2 for all x between 1 and 4. And the question says, how small can f of 4 possibly be? What is the smallest value of f of 4 could be gained as a conclusion or by the conclusion of the mean value theorem? What is the smallest, how small he said, what is the smallest possible value for f of 4 for a given function satisfying the given conditions? Can you do it please and give me the answer in the chats? Yeah, Osama said 16. Let me see another one. Let me see another answer. So either to confirm your colleague answer or you give me another answer. أسامة قال الجواب 16 مباشرة. 18 and above. الماء. Okay, what about the others here? Yes. I will give you some time to do it, but I will check only the names of 2 students I always mentioned, but no response. Let me mention them again. I guess Abdul Rahman. Okay, let me see. Here. I have Mr. Suhail Ayman Sulum. Suhail is not here. And Abdurrahman Khalid. Is he around? Abdurrahman? Mathan? Okay, good. طيب. Let's forget about this. What is the answer? Can you show me your answers, all of you, in the chat? فقط 3 طلاب اللي استطاعوا يحلوا السؤال. 2 قالوا 16 واحد قال 18. What about the others? Can you participate please? Abdurrahman 16 also. فيصل يقول
دكتور.
16. Yes.
معلش الاسم الطالبين اللي تو.
Are you one of them?
لا بس عشان اتكلم في الجروب.
لا already I send them an email. Don't worry. يعني واحد منهم رد على قال انه راح اسحب من الجامعة بس لسه ما سحب يعني هو ما قاعد يحضر في نفس الوقت ما قاعد يسحب يعني ف this is a problem actually لأن it is my responsibility if someone is not attending at all and did not tell the administration. بعد كده لا سمح الله يصير أي شيء يكون في مسؤوليتك. أنتم سامعين بالقصة اللي صارت العام الماضي. We do not need to repeat something like this. Okay, Khalid, is it clear now for you? Yes, the sound is clear now, Khalid. Khalid مشوف. Okay, الأغلب يقول 16. Let us check our answers now.
ايه وضحت معلش كان المشكلة عندي.
Okay, good. Now we will apply the mean value theorem in which interval? We will apply the mean value theorem. I will say apply the mean value theorem on the interval, of course, the given
1 to 4.
interval 1, 4. And since the function is the differentiable, so I will say directly condition number 1, condition number 2 are satisfied. By the mean value theorem, there is a C between the point 1 and 4 that give us the following, such that f of prime of C must be equal to f of 4 minus f of 1 that is equal to 10 divided by 4 minus 1 that's equal to 3. But we know that since f prime of x is always greater than or equal to 2. So this implies f of 4, I don't know if this will be good to write here, but let me take it to the second page, because otherwise in the printout it will give you a blank page then. So let me say like this. Okay, I will take this one a little bit down, no problem. كله بسبب السؤال هذاك اللي ما قدرنا إلى مساحة كافية. Anyhow, no problem. This is the one of the problems with online teaching. You need to estimate it correctly, otherwise you'll waste your time during the class. Anyhow, no problem. So what do we have here is we said f of 4, I will say here, since, such that the reason of the conclusion, since we have f prime of x, he said what? Greater than or less than equal to? Greater than equal to 2. Greater than equal to 2. So this implies. نجي ناخذ الكلام اللي كتبناه هنا f prime of c. So f of 4 minus 10 over 3. f of 4 minus 10 over 3. Is it over 3? Yes, 3 over 3. Supposed to be greater than equal to 2. طبعا if you multiply by 3, and add 10, this will give you 3 by 2 is 6 plus 10, that is 16. So the minimum value of f of 4 could be equal to 16, and this is drawn by the mean value theorem. هذا النوع ثاني من المسائل ظهر في الفاينل اكزام، وكثير يظهر في الفاينل اكزام، وايضا في الكتاب كثير موجود مسائل زي كذا. I left an exercise for you. I need you to share the solution in the group. And this is a question came in a final exam. وهذا يختبر الطالب مش في الكالكوليشن بارت حق المين فاليو ثيورم، لا. He tested the students in the conditions. مو بعض الطلاب مع الفترة ينسى الكونديشنز هذه، خلاص يطبق المين فاليو ثيورم ويوجد الجواب. لكن he need to test you in the conditions. What are the conditions here? السؤال يقول if the function given here, which is a piecewise defined function, that satisfies the hypothesis, يعني conditions, the hypothesis of the mean value theorem, the requirements of the mean value theorem, then find the value of m plus r plus q. I will illustrate the idea for you. We have an interval here. The interval is مين يقول between
Is it 0 and 3?
0
3.
0 and 3. أحسنت. 0 and 3. This function must be continuous on that interval. لما أقول continuous over a closed interval, يعني it must be continuous from the right at 0. It must be continuous from the left at 3. It must be continuous in between 0 and 3. يعني it must be continuous at 2. واضحة؟ هذه النقطة الأولى. بعد كده I will find the derivative. إذا تتذكروا we said we remove the equality. خلاص we remove the equality signs. Then I should have it, the derivative from the right of 2 is equal to the derivative from the left of 2. Please apply these things I mentioned and try to find m and r and q. طيب الآن we have very interesting result about the derivative from now and so on. لا ننسى الهدف الأساس حقنا. Our study here, starting from 4.1, we said up to the end of 4.3 is to see the effect of the derivative over the graph of the function. When do we have a maximum? When do we have a minimum? When do we have local maximum? When do we have a local minimum? We know from before, what is the derivative of a constant function? When you good. What is the derivative of a constant? أحسن, 0.
0.
طيب, do we have other functions different from 0 whose derivative is equal to 0 over an open interval? النظرية هذه جاوب السؤال. تقول if the derivative is 0 over an open interval AB, then f must be constant. ما ممكن تكون غير الكونستانت. f must be what? Constants. Okay, I will try to prove these things for you, and maybe I will not write it in the note, but I will write for you. You can write it if you like, no problem. I will illustrate the two theorems here, how to prove them, and then you have the freedom to write it down or not. Maybe I can shift this one if I need to write the proof to the second page. No problem, I will see if the space is enough or not. Let me just take it a little bit down and share with you the idea how to prove Okay, I decided to take this one to the other. Okay, cut it from here and put it somewhere here. Okay. I will put this one up, and before that one, let me, oops. Okay, sorry for this, but we will rearrange them and then we will solve them together. Okay, let's come back to the proof of these theorems. We have two theorems. We have a theorem and corollary. لما يقولوا في الرياضيات theorem يعني نظرية، لما يقولوا corollary يعني نتيجة من النظرية هذه. Okay, so what is the proof of the theorem number 5? Okay, I will start proving number 5 first. Number 5. طيب الآن لما أجي أثبت أنا proof of this. How to prove that a function is constant؟ شلون يعني؟ لو واحد قال لك الآن أنت معطاه فترة عندك AB. We need you to prove that it is constant everywhere here. إيش لازم تسوي؟ إيش لازم تثبت يعني؟ متى تكون الدالة constant؟ You will take two arbitrary numbers x1 and what? x2 عشوائيا. وأنا أقول مثلا x1 less than x2. وراح تثبت أن f of x1 equal to what? Equal to what? f of x2. يعني كل النقاط متساوية الإيمج. All of them, they have the same image. In that case, we say that the function is what? Constant. And that's exactly what I will do in the exercise here. In the exercise, which is the theorem. يعني. I will say let x1 and x2 belong to this interval AB. What we need to do, we need to show, I will also assume that say that x1 is مو واحد منهم لازم أصغر من الثاني. So usually we say without laws of generality, we will assume that x1 is less than x2. إما ال x1 أقل من x2 أو x2 is less than x1, does it make a difference? These are names. Assume x1 less than x2. What we need to show is this. We need to show that what? F of x1 is equal to what? Is equal to f of x2. Okay, so that's what we need to show. I will tell you to do the following. I will request you to do the following. We will apply the mean value theorem on which interval? On the interval x1, x2. السؤال الآن, are the two conditions satisfied, number 1 and number 2 in the mean value theorem? Are they satisfied? طلع النظرية تقول f prime of x equal to 0 for all x in the interval. يعني the function is differentiable everywhere in the interval, so it will be what? Continuous in the closed interval x1, x2, because this is a subset of that interval. هذه فترة شنو هو؟ It is a subset of the interval A, B. So yes, both of the conditions are satisfied. So by the mean value theorem, there is what? There is a number C. وين يقع النمبر هذا? Between x1 and x2. Such that what? F prime, لاحظوا, F prime of C must be equal to f of x1 minus f of x2 divided by x2 minus x1. أنا عكستها ما تفرق طبعا, لو عكسناها صحيحة أيضا العبارة ما فيها شيء, لكن let me move with the same order we have before. So f of x2 minus f of x1. طيب يا شباب الآن f prime of C كم يساوي؟ What is it equal to?
Zero.
And it's equal to 0 for all points. طيب إذا عندي شغلة كسرية x2 طبعا لا يساوي x1, يعني x2 minus x1 is not 0. Which one of them will be equal to 0? The numerator, isn't it? The numerator is equal to 0. طيب وإذا وضعنا f of x2, the numerator, minus f of x1 equal to 0. إيش ينتج لي الآن؟ ينتج لي شنو؟ f of x2 is equal to f of. وإحنا اخترنا نقطتين عشوائية في داخل الفترة, ووضحنا أن دائما القيم متساوية. يعني شنو؟ F is equal to what? Constant. هذا معنى F is constant. F is identically constant. Always the images are the same. يعني الدالة شنو؟ constant. طيب من يقول لي فكرة فقط، بس فكرة، ما أبغى جواب، فقط فكرة استنتاج اللي هو النتيجة من النظرية، واعطيه 10 درجات بونص فقط. سهلة جدا جدا. ودي اليوم اعطي واحد بونص فقط. الكولري هذه شلون نثبتها؟ يعني سريع جدا. I will give you only 30 seconds. No need to search for anything. Give me the idea if you have any. The idea is very simple here. Okay, the chance is over because I don't like anybody to go and search for the solution. If you have any idea, please, before I close this page.
Sir,
Yes.
I think because it's constant and the slope of the derivative is 0.
No. شلون نستنتج النظرية هذه من النظرية السابقة؟ يسموها نتيجة إلى النظرية. سهلة جدا ترى. فأنا أقول لكم شلون.
minus constant equal constant.
No, 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 no.
بما إنه الميل ثابت هنا وهنا.
أوكي.
بما إنه الميل ثابت في F و G.
أوكي.
F ناقص G لأنه الميل ثابت F ثابت و G ثابت. فلما نطرحهم
هو ما قال إن الإف برايم equal to G برايم فقط. فلوش شلون نثبت إنهم يفترقوا بكونستانت؟ يعني واحدة أكثر من الثانية فقط بكونستانت. معنى السؤال زي كذا. شوفوا الآن الإكس سكوارد هذه والإكس سكوارد بلس 1 الميل حقهم متساوي. هذه F وهذه G. الميل حقهم متساوي 2x 2x. ولهذا هم عبارة عن إزاحة vertical translation only. ترى مرة سهل السؤال. شوفوا الجواب شلون. الآن احنا معطى أن الإف برايم equal to G برايم. راح نعرف دالة اسمها H of X. هذه الدالة عبارة عن F of X minus G of X. الآن قولوا لي الآن H برايم هنا شو يساوي؟
الفرق بين
F برايم
F برايم minus G برايم. يعني معطى عندي أن ال H برايم of X يساوي يعني
سي
0. لأن F برايم minus G برايم والإف برايم تساوي الجي برايم. يعني الديريفيتيف يساوي 0. وإذا كان الديريفيتيف يساوي 0 شو نقول عن ال H نفسها؟ constant. خلاص انقلوا الجي الطرف الثاني وانتهينا. يصير G of X plus C. As simple as this. As simple as this. الآن نبغى نثبت أن ال F equal to G plus C. احنا عندنا F برايم equal to G برايم. عرفنا دالة سميناها H of X عبارة عن الفرق بين الدالتين F minus G. هذه سميناها H. الآن H برايم يساوي 0 حسب النظرية السابقة. إذا كان H برايم equal to 0 يعني F minus G لازم يكون constant. يعني F equal to G plus C. Geometrically it means one of them is just a vertical translation from the second one. طيب الآن وين نستخدم النظرية هذه؟ وهذا آخر جزئية في الدرس. I will do one exercise and I will leave the second one for you. I will write it in details and post it as a note. واحدة من طرق إثبات إن two sides are equal in mathematics هذه النظرية. تارة صعب إنك تبسط وكذا وتوصل إلى الطرف الآخر. لكن you can prove that the derivative of the left hand side equal to the derivative of the right hand side. Okay, if the derivative of the left hand side equal to the derivative of the right hand side يعني they differ by a constant, then you need to prove that that constant is really equal to 0. الآن احنا راح نعمل الشكل التالي. راح نستخدم الجزء اللي هي نظرية أول اللي هي الجزء الأول من اللي هي نمبر 5 يعني. I will define a function f of x. أسميها tangent inverse of x. ما راح ياخذ دقيقة الحل. plus cotangent inverse of x. تمام. وأسألكم الآن سؤال. What is the derivative of this function? What is f prime of x? شو الجواب؟ What is derivative of tangent inverse? 1 over 1 plus what? x squared. cotangent inverse minus 1 over 1 plus x squared. تتذكر القواعد هذه. What is the answer here? 0. طيب إذا كان f prime is equal to 0 هذا حسب النظرية الآن by theorem 5 by theorem number 5. What can we gain about this? F must be what? F of x must be constant, isn't it? Constant. الآن يبقى لنا الآن يوجد الكونستانت هذا. Okay, I will take this one for the time being downstairs. Okay, we do not need it right now. If this is constant, what does it mean? And this implies, let me just take the pen again. This implies, sorry, this implies what? This implies what? What is f of x? Tangent inverse of x plus cotangent inverse of x equal to constant. طيب باقي لنا نثبت ان الكونستانت هذا هو باي اوفر 2. اخذوا لي نقطه داخل المجال. take مثلا واحده سهله جدا الحساب. take x equal to 1 مثلا. اوكي and substitute. مو constant يعني مهما عوض عن قيمه الاكس لازم يطلع نفس الجواب. اخذ نقطه سهله 0 باي اوفر 2 سوري يا 0 1 وات ايفر يو لايك. الان ما اعوض بالواحد tangent inverse of 1 شو يساوي؟
باي باي 4
باي
باي
اوفر
اوفر 4 احسنت. وكوتانجنت انفرس اوف 1 also باي اوفر 4. لا مش نيجاتيف كوتانجنت
يس
باي اوفر 4.
أيوة.
هذا يساوي الكونستانت حقنا. يعني الكونستانت حقنا شو يساوي؟ سي ايكوال تو باي اوفر 2. وبالطريقه هذه اثبتنا اذا tangent inverse of x plus cotangent inverse of x is really equal to pi over 2, and that is the conclusion of section 4.2. I will add another exercise. You can see it downstairs here, and I will write the solution for you, and then I will post the note for you for this section. يعني باختصار شديد, if you cannot prove that two quantities are equal, تبغى تثبت ان ال f equal to g, ما استطعت. هل تستطيع تثبت ان f prime equal to g prime? If you can do this, you can show that f equal to g, because at that time you are proving that f equal to g plus constant, and then you need to show that this constant is really equal to 0. Or you can take f minus g and show that the derivative is 0, so the answer equal to constant. Then you plug a point inside the domain and find that constant. Okay, that's it for the class today. Thank you for your patience, and I will inshallah complete the second exercise and post it for you. If you have questions, yeah, please ask your question.
دكتور
Go ahead.
فالسؤال الأخير لو أخذنا الإكس equal to 0